Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation, just kind of freestyling, talking about anything, trying to get what I would call physically renormalize, but just, we've discussed a lot of logic. Again, we're on part 267, 8, whatever. But trying to finalize, trying to find this iteration, this sequence of letters. I'm talking logically right now. We're going to start over with physics here in a second. We're trying to find this stabilizing sequence of letters, a unique series of syllability, it's a structure of logic, to prove sensorality, which is a definition, sen, sor. There's some linguistic elements. S is really like an iteration placeholder. N and or is a word. Y represents the sound E. So I'm a person, I'm Brad. I think really a lot about words a lot. Not a lot, but it's just, again, words are representation of physical processes. And so we have ing, we have this sound, and we have a word for that, that is vibration. And that is the basis, the logical, physical basis of all words. And those words have meaning, right? I have a cell phone, I have a notebook, I have sweatpants on, I have a sweatshirt on, I have a hat on. And so we've differentiated vibration, and those meanings cannot be reduced past a certain limit. And that limit has a numeral associated with it too. And so then we try to describe the world around us, and then we're already introduced into a world with words. So again, you can't reduce words. And so the words are built on sounds, and there's logic to sound. That's how the word's stabilized. And so we have these two sounds, ing and e. And so e is represented by the symbol typically in English as y. And then you have, right, testing is how I started out this day talking to my microphone. Again, I'm trying to derive it right now, but it is what it is what is ing to it? It is a noun, ing is a sound. And so we're deriving logically. I'm a physical being talking. I did just smoke some weed, but that's really not the point. I'm just saying that anything that comes to mind. And so, trying to physically renormalize. And again, we started with sounds, I'm a person, and so I just reduced logic in words, and we're trying to put those pieces together. And so we're at this numeral, this logical derivation of sensorality, where there's n and or. And we're trying to show those sounds going up into other words, but they're already contained in words, so we're starting with sentences, and we're trying to reduce and show this stabilizing syllability, sequence of letters. And so, okay, that was my intro again. Just trying to, again, like I'm trying to show you every bit of progression of logic, because it's a physical process. And so, but again, it really is relevant because I've already done this and I've already derived this, not in the sense of like the right answer is already out there, and I'm trying to articulate it and show it again from first principle. But last time, what did I say that I wanted to start with? But we're just trying to build up this model. So that'd be the next operative word, is model. And a model is what people would call a theory, I guess, but it just it shows the consistency of those sounds. And so we have two physical principles: vibration, again, that's a representation of ing, so the word representing ing. And then we all already exist in a world where movement exists. And so we have this model called language, and these words make up languages, but really it's just language. And the meaning is what is the base, or the sound is the base, and the meaning is associated to the base. But I can't reduce that, that's why I'm talking all cumbersome right now. But, so we have a model, those models of words or language, and you already existed in a world with movement, and that movement is represented by the word rhythm. And so we have this physical base of vibration that had stabilized into energy, and then there was light. It was in a book that people kind of read before. But light's not the right word. It's radiation, because you have this numeric progression of elementality, one thing. And so we go from ing, and then we put this th, consonants breaks resonance. And so I even had that written down. But really, converse is the inverse of resonance. And so you assert something exists, but you don't assert anything. Things just exist. Then we're trying to describe those things. Then we have to build up our model, so now we're using more words. We're going to sound less cumbersome and weird. But we have these two physical principles, vibration, which is really derived and inferred, but then we would say information is contained within systems. The same way you grow up and you learned, the universe grew up and it learned. And so that's why you say vibration, that's why you say light, but really it's radiation kind of encapsulates both concepts, right? Because when you see radiation, you're kind of thinking of like a wave. And that's where physicists say waves. But waves are emergent, just like we're emergent. Hey, Brad here again. Yeah, again, just literally just trying to say anything that comes to mind. But then, so we have the particle and wave, we have duality, but then we have individuality, right? And that represents the one, two, many. So then we have our counting system with numbers. And numbers, and then when people don't know when people try to articulate something they don't know, they say like number. But there's a lot more ums than there are ings. There's a lot more unknowns than there are knowns. And so that set of knowns is bounded. So there's not a physical boundary to what's been called the universe. There's just transmission limits. And so that is what has been called the observable universe. And then shit's still moving around, but shit is localized, right? And so those local things all would act like spheres. And so then you have pi r squared, just think of, or 4/3 pi r cubed. Then you have volume. So volume is space, but volume exists, the things with mass, objects have mass, and they contain the space. So objects contain space. And those things are independent. There's nothing in between those things. It's just the things. And they're all squished because there's other things around them. And all of those things are moving or trying to move, so they're vibrating. And then vibrating equates to a cycle that doesn't do work. But to not do work, to do work, you need movement. And Isaac Newton tried to do something with that. But where was I? Fuck. So movement exists. Things are moving or trying to move. And so vibration is a cycle that doesn't do work. But a cycle means you return to the same starting position. But the positions are based on the things that are moving. So that's what's called dynamic. And so everything is dynamic, everything is moving. When you have a measurement, you're using a physical system that it's all moving, trying to measure or interact with something else that's all moving. And so you have error. And that is inconsistency in representing what fundamentally exists. And then you have other people also experiencing that. And that's called life. And then you look around and say, what life is like me? And then you have this thing called the law, because everybody else is looking around like, what's life like for me? And then you have a bunch of people saying, or individuals saying, that's not me, that's not me, that's not me. And then they fight a lot. And that kind of stinks. But it's kind of gonna move on past that pretty quick in the grand scheme of things. But then you have schemes, and you have themes, and then you really have order, which comes from the physical things. And so now we're in this arena where, again, we've inferred these fundamental phase changes, but we had our first measurement, and we called that entropy. And there was no entropy, and then there was light, but there wasn't light. Again, that's still wrong. But that's the story that we've all told each other, and we have to break through the chains and associate the right words to the right physical processes. So that's where vibration and rhythm come into play. And so, yeah. And then there's temperature. Again, those things with mass are trying to vibrate, or they're trying to move, but they can't really move, so then they kind of jiggle around, which we call that vibration. And that vibration is temperature. And so then we're all called ourselves thermodynamic system, or thermodynamic. Yeah, we're thermodynamic. And then we have thermometers, right? Then we have invention, we have tools. And those tools, we use the word measurements. But measurements are already well defined. It's a measure, right? How many beats per minute? Go ask the musicians. And those people are really old too, and they were also called mathematicians or musicians. Who knows? We have names, and names differentiate those individual things. That's all those things are not things or objects. They're people, or sometimes we call them humans. But there's names for different organisms. Then we have groups of things that are moving, and those are called organisms. But modern scientists think that's just one individual, but it's really one sentience. Organisms produce sentience. And so then we started forming sentences. You go do this, you go do this. And then we're back to the rules and the laws kind of argument, and we started arguing. We've been doing that for a while. But back to physics. And so then, basically, a bunch of people started noticing those things were discrete. They didn't really notice the physical limits. They definitely didn't notice that infinity is well defined, because there's not a physical boundary anywhere, and that things have natural inverses. And so opposition exists, as we talked last episode, but it's like local. It's within this locality because of that bounding of physical things. And so the biggest mathematical concept that society has not known is inversion. And so sometimes that inversion, we have to say the C word, chirality. And so, but that's really just a reflection of our geometry, again, this fundamental stability of 2. We're getting there, kind of. But this is what first principle scientist is. Like, you don't really introduce anything, you derive everything. And so then there's a guy named Brad, just again, so I'm here looking at my camera, kind of stoned, but it doesn't really matter. Let's be very clear here. I'm just telling you anything that comes to mind. I did smoke the bong, but that truly has no impact on anything, which has caused a big problem throughout society called the Controlled Substance Act in the United States of America. Back to physics. We're trying to focus on the physics here. But it's hard to when the laws aren't respected and you can't feel safe and stable and pay your bills comfortably, and then you have to try to do science, and then it all looks kind of funny and it's all jammed together. But anyway, trying to get back to physics, which I've been trying to do since I've been like 6 years old. Because then they're talking about unifying physics, and I'm over here like, you don't unify physics. Conceptually, that means integration. You want to integrate, but we have to understand chronology. And things existed, and then there's this things, you say not that thing. That's kind of an inversion. And so, back to the mathematical concepts for now. The inversion. Right? So people will say all of the time, you have an inverse. And if you have one more letter, you have a universe. And so that's a fundamental iteration of universe and inverse. But mathematically, this inverse, you can't have nothing. Right? The opposite of nothing would be the open phase change that we're currently existing in. What I've called R3, but is really stabilize 2 things and then not this phase change, put a pot of water on the stove, and the temperature doesn't change. All of the energy, the potential for movement, that either going to vibration or rhythm. And then to make any physical process most efficient, it forms a rhythm, just movement, it being movement. And then, back to inversion, again, it's represented in chemistry. The entirety of chemistry derives from chirality, linguistically, logically, in science class right now. You kind of get these things called polarity, but then you really have stability called pH, measuring acidity versus basicness. But then you have this, again, this physical limit of 7. And then you have that, again, your blastocyst differentiates 7 times to form one person or thing. And then you have this numeric representation of 7, and then the letter 8 being the same as the thing is called infinity. And back to inversion, mathematicians have realized that infinity is well defined. So when they say you can't divide by 0, that's true because it's not a thing. But you can, infinity is well defined. So there is an inverse to that, and that is called infinitesimality. And that is represented linguistically by all of the words, literally all of the words that end in I-L-I-T-Y. And so Then there's a whole massive chunk of what's called mathematics that nobody at these great institutions like the Ohio State University, Harvard, or Cambridge, or Oxford, or Bologna has ever even like kind of even began to like started articulating. So then we're back to like trying to tell people that you don't unify physics, you just do mathematical proof. But to do mathematical proof, it kind of takes a while because you actually have to do a lot of shit. And then they're just like, oh, the Riemann-Moids, hypothesoids. And you're like, oh shit, not this shit again. So back to inversion. And so because infinity is well defined, it has an inverse. And again, infinity is the awareness. The universe, there's logical bounds to our system of what we can talk about. And so when people say, what is the edge of the universe? They're trying to ask, what is the inverse of the universe, which is nothing. But again, we're progressing. Things are going forward. And so what you're running into with that question is a logical bound. And so logical bounds exist because systems are discrete. And so thing becomes system, but right, thing is the representation of the vibration, and then consonants th-ing. And then you get ways to count things. And then that's because of order. And you have the word ordinality, which we just completed on part 260. Like and subscribe, pay me all of my money. But anyway, we move forward. Back to inversion. And so because infinity is well defined, and they'll say, you can't divide by infinity, which that is undefined. So that's a valid point. There's a valid point there. But the point being is infinity, all mathematical concepts emerge from and thus relate to physical systems. So what are we representing? And then we have growth rates that are different. And as anybody who has ever learned to do calculation has done, you might hear the word subtraction or division, but you're doing some form of a forward progressing operator. And so you operate forwardly. Nice. Like and subscribe. But then, back to inversion. So we have these growth rates that are happening physically, and those come from entropy, something to do with heat, temperature. Things are getting cooler. Our locality internally has obviously a lot of difference. My notebook is a different shape than my cell phone, than my chair, than me. Back to inversion, or not inversion now, growth rate difference, right? And we have this word called puberty, where we all know what that is. But we have inflation, which is real, and now somehow the physicists knew it was real, but then now they're like asking if it's still real, and it is. A rapid expansion. But what expanded? Because our concept of range is domain. Domain. And so, but that is internal. Like when my voice sounds really resonant, you probably think I'm having fun with this, obviously. But the range, the physical definition of range or domain is not out there. It is not further away. It is more comprehensivity with your vocal expression, to use an example. The people that can sing, that get paid a lot of money, that go on world tours, their vocal range is not defined by screaming. Right? How soft can you sing? Would make a lot of sense to people who can sing. But regardless, the concept of range. So we have this relationship of things that exist, and to use the boundary of infinity, which is really a physical awareness of things that actually exist in the real world, like me, like notebooks, but then the ability to transmit information from those things is limited. And then our word system, our language, is bounded within that logical reality of order. Things bump into one another. If I click send, it can't go faster than what's called the speed of light. And light's a bad word. Light's a very bad word. Chirality we're kind of getting used to now, but light is still a bad, naughty word. But anyway, so we have these system evolution changes, and then we can just ask in general, what physically is changing? And it's the temperature, right? If you cool down, the reason people eat and organisms and life eats is because of to sustain heat, right? That's why every biological system will tend to like hot food. Well, that might be a local limit within, but any mammal certainly, any mammal, yeah, because then again, I can't even say that for like reptiles or amphibians, as known. But mammals like hot food, but it's all, again, to preserve a calorie is a unit of heat. And so what's happening is everything's getting cooler, and it takes a lot of energy, a lot of work to sustain that heat level. That's why you eat, right? That's why you have cities. That's why everything's concentrated around stars. And so that is what's physically dissipating, is entropy. No, so now we have, again, energy is the thing that exists, or movement exists. Energy represents the potential for that movement. And then when things move, nothing is efficient. Rhythm maximizes the efficiency of that movement. Again, vibration is more of a degeneration limit of rhythm. Rhythm is the thing that we're all interacting with, and that's represented physically as momentum. And that's open, represented logically by ending in And so, not even to our theorems yet. We're doing pretty good. We're making good progress. And then, again, this rate change. Why do we have certain functions growing, and it's still growth, growing faster than other functions? If you take every natural number, again, logically, natural number, whole number, if you just add one, and again, infinity is not a number. And so if you add up all of the numbers, which is bounded logically, it just gets bigger and bigger and bigger. That's right. There's no bound to that. It's dichotomistic. There's no bound to that physically. And so it just gets bigger and bigger forever. But that's not infinity. And so but then you have things that get bigger slower than other things that get bigger and bigger. You have two things. Exponentiation gets bigger faster than addition or even multiplication. And there's a difference between multiplication and addition, obviously, but the rate of difference between addition and multiplication is slower than that between multiplication and exponentiation. That's obviously. And so those are our functions. And then it pairs to, again, entropy, but it's not. The state of low entropy is our knowledge bound of physics. And so a state of extreme order, and that's what's a phase change. So then last time I said, the universe, which again we just inversed the universe, uniterated something happened. But I said the universe was hot and not dense. But again, that's kind of the logical bound of me trying to show you that you can't not conceptualize movement. And so it's much more equivalent to just if you think of like a cube, or if you just take a bunch of particles, a bunch of grains of sand, and vibrate them on a plate right now in physics class, and it kind of just forms those resonance patterns. That's what's contracting, and that's without charge. And so then we have this thing, James Clerk Maxwell, but magnetism, to me, the physical reality of no magnetic monopoles existing, that is the stability. And then we have locality of charge, and then all charge acts as a magnet, induces a magnetic field. And so the momentum of magnetic fields is what's the big thing that moves shit really, really fast. And science team has some super spaceships that they're not telling anybody about. But we can figure it out. And there's more than one we, but Brad's the best at this kind of stuff. But we can't talk about that. It's really just not really relevant to our derivation. Anyway, back to growth rates. But no, the physical formation. There's no way to conceptualize a physical system without movement, because again, geometry is this physical stability. I mean, you've never not interacted with things. You can't. I'm deriving the whole logical language structure that we have right now. That's why it sounds a little different. But there's literally a physical logical limit, and you can't say or do anything more. That's demonstration of irreducibility. And so, but regardless, we have this what's called entropy, which is the logical inverse of energy, right? A sound wave. When I'm literally speaking to you to this camera so that you're watching on this video and you think, wow, why does this guy sound so weird? And someone's going to probably leave a shitty comment because ontological shock. But regardless, interference messes up your ability to do work. But then So energy and entropy are physical and logical inverses that are well articulated throughout, for the most part, well articulated throughout known physics. But again, really you start with movement, and then you have the potential for movement, and that is bounded, and that's, again, nothing can be created or destroyed physically, that being the word mass. Whether you ask a person in religion or in science class, it's the same word. So then again, we're back to people doing weird stuff, but again, for the most part, that's going to go away, and over any relevant time frame, which is just a measure of inefficiency. People had a kind of a blip about what is time. It's just measuring things doing shit, and it's not going to be perfect, so some time passes, and it makes sense to... It's 2026, so yeah, hope see you on Wednesday, Bill. See you at the office. To do more work. But then industry comes along and we don't really have to do that much work, and psychologically human beings don't really get that. But the motto of the future is going to be do less, chill. And it's not going to be just Netflix and chill, it's going to be chill and then more chilling, and everyone's rich as shit. And then they're going to be like, why didn't we do that faster? So let's get to tomorrow faster. But then we never get to tomorrow. And so we have conceptual bounds. We'll get back to energy and entropy. But tomorrow never gets here, and the past is always in the past, or always, yesterday is always in the past. So then we have our time bounds conceptually. And people love those ones. We always talk about tomorrow never gets here and slap ourselves on the back, and then we kind of realize that we're all realizing the same shit, and we have cliches, and then French, and then the Germans, and then the order of the languages I don't know, and it's really irrelevant. They're just internal consistency. And we've proven and demonstrated there's a lot more logic behind what a language is, and even the concept of language is bounded as one thing, which we introduced rather well, if I do say so myself. But anyway, so then we have this inverse of energy and entropy. Energy is really a representation of mass, thanks Albert Einstein, great classic dude. E equals mc squared, nice. But the potential for movement. And then if you split atoms, human beings, let's go throw that on the Japs. From the United States. Bad Truman Show. But again, that's a classic theme. And then people start arguing who's doing the more dumb shit. And it's just like, that's hypocrisy. There's a whole word for it. And then the people that get remembered in history are the ones like, hey guys, everyone's kind of doing this dumb shit. But then they actually kind of like stop doing the dumb shit. And then money forms, but which is a whole nother. Let's stay with energy and entropy for now. But you have the potential for movement, which is inferred more or less from things moving. You said, can that thing? What would its potential for movement be if it wasn't moving? But that physically doesn't exist, because again, we're back to the things bumping into each other, and that's temperature. But so then we have this physical and logical inverse, energy and entropy. But the thing that exists more so is energy. And so energy, then entropy. And then how do we make the most, right, again, to go from, or to preserve energy is going to degenerate into entropy. This initial state called the Big Bang that you guys fucked that all up too. But the empirical evidence of extremely low entropy is this consequence of chronology where there's two other phase changes. And so you go from entropy to, you limit that entropy, right? Rhythm didn't exist yet, but you limited energy, and then you had no entropy, and then it stabilized again, another physical property, magnetism, and you can localize magnetism into charge. That moving charge induces those magnetic fields. I know we just said that. But it doesn't make sense to, and we're back to that physical, logical, conceptual bound. There's no way to conceptualize like how big anything is, because mass exists, that has form, and there's no form to not mass. And so we have rhythm, not rhythm yet, but just what is recognized as energy, limiting entropy. And then once that gets to zero, you have that phase change recognized as the Big Bang. There's no bouncing, there's no verbs, there's vibes, there's no verbs at this point. There's nothing to move through. You don't move through things. And there's literally movement. It's just, we're all just like packed together. Every galaxy, every super cluster How big is big? I have no fucking idea. And nobody does. That's very, very well established. But anyway, back to energy and entropy. We have these phase changes. That's if the phase changes occur when energy limits entropy. So that's why you have the period of time of extremely low entropy at the beginning of what is measurement. And so that is like 40 million Nobel Prizes right there, because that is logically, truly provably logically derivable, because all of this information is contained within our words and within the physical systems around us. And so that is what has happened. And since then we have mass and things are just, we have rhythm now, and that's what everybody knows is when you're trying to do work or you're trying to limit inefficiency, you form rhythm. Entropy logically maps to what did I just say? Entropy maps to inefficiency. Logically is consistent to the word inefficiency. And so rhythm is efficient, and that's kind of our major axiom. That's where our fundamental physical axioms come from, is the word efficiency. And so what language that gets conceptualized in has remnants, but it doesn't really, the chronology of what we've differentiated, French, German, Spanish, Tagalong, Russian, Swahili, Arabic, it's just differentiation of syllability. And so that's where we have, again, our fundamental theorem of physics is what I would say right now, just jumping ahead, finally looking at my notebook. If you can't see it, again, I just have theorems, but this whole process right now is just, again, first, I wouldn't even say you just start demonstrating stuff. But consonance is the inverse of resonance. And so then all of this logic and geometry is reflected within our words, and it's already packaged up. And so we're just deriving it and trying to build it back up and trying to find the stabilizing syllability. So continuing on, where were we? I was doing pretty good on that. And so yeah, we have energy and entropy are physical inverses. We walked you up to the physical limitations and where our measurements start, and the reason measure exists is we already have a conceptual arena for that. Music, beats per minute, a bar. How many beats, right? Beats is represented by rhythm, as we were just talking about. And then all of what's identified as mathematics, or like research even, is just connecting these different pieces that have differentiated. So we have differentiation. And that differentiation, we just kind of showed that growth, and we live in after these two-dimensional. So then we have this word called dimension, which I'm not a fan of, but I kind of get what it means intuitively, but the word makes direction, right? If you have one thing, all you can go is one way. And so then you have a two-way street. And then you have a two-way street and the z-axis. Or you have orthogonality. You have not a plane. You have a string, really, right? A string is the physical thing, and that explains string theory, but the word theory is illegal. The word light is going to get banned pretty soon. The word radiation needs to make a big comeback. But then we have geometry, and so we have all of these things, and they have shape. And so the things that do have mass, you can't measure that specifically, but again, measurement is more of a containment. And so physically. And then we have all of this great, wonderful subject identified as geometry. Geometry is shape and how those shapes relate to one another. And if you throw in, they also say the word topography, but that's really just shapes if you don't try to knock them down to two dimensions, because geometry already means geography and geopolitics and geo. And once again, we have these forms of words we can't break down because everyone knows what they mean. And so, yeah. So then we have a bunch of words, and we're all sitting here, and my name's Brad, and I'm still pissed off about this shit called the law that's not really kicking in. And I really don't even care about that. I just want some money so I can go do things like hiking, because I've already solved all of science. And people that are still wondering over, what's my name? How do I spell it? What's a square and a triangle in Riemann's hypothesis? Oh my gee golly willikers. And I'm like, yo, okay, I dipped out like a long time ago. Can I just get some money? And people will think that's a joke, but it's in no way a joke. Since about age like 12, it's like, okay, Johnny and Billy are doing weird shit. But if I just get some tokens, I can go play at the arcade all day and I don't have to watch Johnny and Joey do weird shit. I can just, and that weird shit's called chasing a career. That weird shit's called, a lot of times, I don't actually, not even against sports. I don't have a problem with sports. I just have an extreme aversion, a difference to seeing major institutions that are supposed to be educational structures not prioritizing education at all, period, clearly. They're not even, the people are too stupid to know what to do, honestly, and they just think it's not them, which is a classic case. But anyway, back to physics. That's a whole, that's always happening, and it's always relevant. Because that slowed down the derivation. So since age 12, I've been over here like, holy shit, how do I just like get away from Johnny and Joey? Just, they're all doing their weird stuff, but I need some money, and if I can get money, then I can go do stuff. But anyway, back to the derivation. We have derivation, which again, we have this concept called calculus, or where we had people. And those people told stories. And those stories have limits. And that knowledge is really limited by what everybody knows, not what any one individual knows. And then that, we are still pretty primitive to what we call technology, but we're sufficiently technologicalized where I can sit down and say everything I want to right here on a camera and post it up on the YouTube, and anyone who wants to watch it can click on it. So we can spread information, and that's what's been called transportation. And so technology existed, but then the biggest technology has been and kind of will be transportation. So then we can move all of our goods and services around the globe and around more than the globe. And then when we can do that and we start toting around big nuclear warheads, then we get some friends and they're like, hey guys, what are we doing? And but that's Johnny and Joey are still doing weird shit. So we'll let them do their weird shit. Anyway, back to science. And then science is this collective sentience from everybody. And it's all represented in these words that have meaning, and we're just trying to form orders to those words, and that increases work. And then if you do that, you get some more money. But unless you're me, then you still don't get any money because no one gives a flying fuck about the law. And that's like the biggest thing that people don't realize is in the future, people are going to look back at this period of history and be like, what the fuck? Because you can't break the law. And then of physics as a prepositional phrase. But you can try to. And it's just like that period socio-ecologically will last for a substantial amount of time for any one individual. But I think even the medium history of things, it's like, what the fuck? But anyway, back to the physics. And so, yeah, but then you have completeness. Because we have these boundaries, you have completeness. And physicists are still at Harvard and Cambridge scratching their head. They don't know anything because they're jerking off. They're not stupid, but they've groupthink their way through to nothing. And they're just kind of like, yeah. And then so my big revelation was, hey guys, words have meaning. I have a little bit of inclination to associate those words, but that's really all I've said. And then I say I can demonstrate that. And then I got cast out of all of society, and that was fun. But anyway, we got the job done. And so we renormalized kind of like everything. But there's not that many things. Conceptually, we have these boundary, right? Don't die, which is you hit the ground running with that one. And then you want to reproduce, if you get lucky enough. I would like a female and companion. Have not locked that in, as the kids would say. But then you have, again, the concept of, I don't even want to say the concept of, then you just have organisms living their lives, trying to not die, reproduce, and then think. And then thinking is actually, it's more of a biological, genetic thing. I don't want to say, thinking is well defined as resistance. It's just trying to figure shit out. But there is an inclination, and then we get back over to Secret Science Team, where, again, what really differentiates, what is a meaningful differentiation of sentience, of the genetic code, is not publicly disclosed. And again, unless there's going to be a cutoff screen and we're going to hop on over to Secret Science Team, I'll just let that sit for a bit. But regardless, it doesn't really, there's sentience is a section, or a species is a section of sentience. And then, so you have no closed systems, privacy doesn't really exist. People are kind of learning that, even on the more, not just the organisms called humans are learning that as well. And But regardless, it's just physics is a development and a refinement of vocabulary, because words are physical expressions. It's a physical thing. We're all telling a story, and that story has to line up with shit that happens really fast all of the time, and that's why entropy is increasing now. It's because once you stabilize that physical property, magnetism, then you're repulsed, right? And so it's like when the Big Bang, so that's okay, back to why I said I do not like hot and dense, because that magnetism is not hot or dense. It's right, friction, heat, mass bumping into each other, temperature comes from inefficiency. That's literally what temperature is. And so magnetism is stabilized. And so the magnetism is the word that's like magnetic. And then gravity kind of derives from magnetism. But then you just have this dipole, you have polarity, this stabilized physical property. But it comes into, it's the physical stability is why, and then the geometry, because things are the things that occupy space. And so it's like, there's no container, there's no bound, there's nothing like, I've lost my own intuition. Now, we have to be specific with our words. But it's not, this whole concept of what is gravity is not, okay, we'll put that on the table for now. But anyway, and then we have, again, magnetism is the physical property that is stabilized. And because of geometry, or the stabilization, mass creates geometry. And you just bump into each other. But the magnetism is not temperature. It doesn't have temperature. It's not hot. And so, but it's just that it's the fundamental stability, but it has polarity. And so again, it's got to be, again, some sort of internalized dynamic. And so this physical structures, it scales, and that's called fractals, and there's no difference at any of the big and small. There's just a lot more big. Big doesn't necessarily mean, big is not more. We've already done the conceptual physical bound. That is where we're now working in what's called magnitude cardinality numbers, calculation discussion. But the magnets, everything's acting as a magnet. There's one magnetic field. And the word field does not apply to the individual particles. It emerges from the particle's existence and movement. And so when they say that a field exists and then a particle arises, very literally the exact wrong thing opposite. But the magnetism is the word of physics that's kind of like the center of logical physics. I don't know. And so I think that's kind of in a complete model. I mean, that's kind of what we have. But again, the boundary question is not what is bounded, is our, like in logic and physics. I walked you up to that as best as I could, and I think I did a pretty freaking good job. But the observable universe is not a physical boundary, and so we'll just kind of renormalize logically. So infinite, again, the infinity is well defined. That's that awareness. You do have an inverse to it, but fine, right? If somebody says, "How are you doing?" you say, "I'm fine." That is a form of finite. Literally, you're just chopping off the TE. Fine is a form of finite. Finality is fine. Fine is final. Finality completes. Completing does not continue. Continuation is infinite. And again, the finiteness, that existence, the fundamental physical magnet things is what's finite. Sentiality is integrality. Sentiality is grality. Grality, gravity. Tegrality is essential. Egrality is essential. You can derive all of geometric linguistics if you just take a string, which again, it has this like physical bounds again, but literally just take a string, like a piece of yarn, a rope, and have like one unit, and then like try to like bend and cut the unit into different associations, these different shapes we call letters to make these sounds. And you can pretty much derive all of geometric linguistics. And so you can see that with the different curves versus straight lines, closed versus open letters. And then literally if you look at font, like the word font is well defined, the different fonts show you and elicit these different geometric relations among the letters. What is iteration to spin? And so spinning is the rotation in around the word internal makes sense, right? What people will say again, the electron is not a point particle, it's a stabilized dynamic is the logical phrasing you use for all of these things that would be called inferred, but they're not really inferred, it's actually there, it's just limited by measurement. And so iteration to spin, again, iteration is more within cardinality, more within magnitude. We have a set amount of letters, a set amount of numbers, which are really, again, just fundamental physical differentiations. And those physical processes that we talked between addition, multiplication, and exponentiation are like the three that exist. Those are pairing to physical processes, the entropy, energy. But we're in this bound, again, cardinality, magnitude. And so iteration is more of this set procedure when you have a fixed amount of elements and you have to produce an infinite range, an undefined range. And so again, that's logically bounded is why when somebody comments on my channel and says, what is the inverse of infinity, undefined? No, right? Things, I just walked you through that whole, I'm not gonna respond now. Iteration to spin. Spin is rotation, those things that are moving with this magnetic property, they're rotating, and spin is rotation, and there's not a point particle called the electron, all dynamics spin, and so it's represented by quantum mechanics called quantum spin because it's spin, and it's 1.5 because there's only 1 and 2 things, and that's why 1/2 comes up in everything because it's stabilized physical dynamics, and then it's like rooting, that's what you're doing when you're equating something. It is what it is the form of all solutions. Drop down menu, drop down menu, drop down menu. People bickering about Nobel Prizes. Oh, there's a war. Oh, good job, guys. Another prize ceremony. Let's do that again. But what is iteration to spin? That's just what I said it was. Essentiality is essence, right? That was, again, just renormalizing into the theorems I've written down last episode, right? If you're an integral part of something, right, you are essential. And so we have this difference, things that are life we call sentient, and now we're trying to pair up me, a sentient being, as trying to order these different words that already contain meaning because ontology is the set of words with meaning that have relations well defined outside of one individual. And so I'm just connecting ontologically shocking people by saying things that are true because they can't hear things that are true because they've never been outside of groups. And it's not like a big complicated process. They just don't realize how little they think for themselves. And so, yeah, essentiality is essence. Essence is essential. Essence is quality. Quality is essential. So then I have it written down, but I already said or derived. Consonance is the inverse of resonance. And so we have vibration, vowels, verbs. Those verbs produce resonance, and that resonance is consistent, and consonance breaks that resonance. That's why my voice sounds really loud, because I learned how to sing. And so then when you speak in the right words, in the right order, it shocks people. But my voice kind of sounds loud, but that's just because I learned how to sing. That's a physical training, like you go play sports, you go learn how to sing. But linguistically, universe and inverse is some sort of iteration, and that iteration builds, and then you have the Pauli exclusion principle, which to form physical stability of this magnet, you have one thing, and then you have the opposite thing, and then opposites attract, and then opposites stabilize. And so the concept of inversion applies to the universal phase changes, not these localities. Because once you have stability, opposites attract, yin yang, any left, right, up, down, any dichotomy you want to say, you have natural opposition within that bounding, within that stability. And so the opposite, the fundamental theorem of logical physics boundary thing, the logical opposite of the universe is nothing. It's not, infinity is well defined. The universe is what's not known. And so that is what's undefined. And that's what typically people see when they say 1 over the infinite sign with no physical lead-in whatsoever. That's kind of what they're intuitively thinking. But the logical opposite of nothing is the universe, and conversely, the opposite of the universe is nothing. Everything, not one locality. And so within locality, you have opposition. To integrate is to essentiate. Sensuality is essentiated. Feeling is essentiated. You emote. Sensuality is essentiated. To satisfy is to satiate. Sentiate, satiate. Talked about I introduced it as I re-derived it, but they are logical time bounds, right? Tomorrow never gets here. Yesterday is always in the past. And then today is really this process of things have occurred, and now we're trying to like anticipate the things that are going to occur. But then by the time we've anticipated that, those things have occurred. And it's just this process of, okay, fuck it, just make a decision, right? You're trying to like, logic is trying to like this assessment of things of the past to try to predict the future, but it's just always happening. Everything's dynamic. You can't like break that process of things changing. And so call that thinking. And you try to maximize that, and then we're back to rhythm. And so again, trying to pull all of these concepts together, again, very clearly, probably this episode probably seemed different, but just trying to, again, my rights are violated. I'm not joking about the law stuff, obviously. And so there's no point, I've already done this whole process. There is no point for me to continue. All of the pieces are together. It is just to refine, and you already have the form of the word. You already see what I'm getting to or going at, and there's no point to. It's just, again, it's an abuse of, my capacity with language is so neutral. Like it's just there. It's not like good, bad, it's just there. And so, but on a personal level, it's just like, if I feel like if I can get one more thing done, then it's like someone's going to change. And I realized I solved all of science like 7 to 8 years ago. So there's clearly no like present day historical, I mean, I'm Brad talking to my camera, making a YouTube video, blah, blah, blah. Like there's no step that I haven't passed and shown you that would like make something change. It's whenever you guys decide to stop treating me like shit. So please stop doing that. And you can just give me a little bit of money and I can go hiking. And that's kind of what I want to do. But regardless, that is what I have for you today. Obviously, memory is an association. That's the last thing I had written down. But again, trying to pull all these things together. Because again, we're still learning a vocab word. We're just trying to find and ask the right question. Again, all of this logic is contained within a sequence. All right, then we have sequence versus series. And that's really time, tomorrow, somewhere within yesterday versus tomorrow. But the past versus the future. But there's just some differentiation in language that's set and some that's open. And we're trying to show you that moment of breaking to stabilize the past language, including all the videos I've made, all of that stuff. But regardless, it's profoundly illegal to keep treating me like this. And just a little bit of money. A little bit of money. It's again, the actual rate of derivation is a physical limit. So it's not like I'm just making intellectual property, but even at this point, it's like I've done this so much, it's like, what's one more video? It doesn't really matter. But I tried to attempt to derive kind of and build all of known physics and mathematics. Got pretty far. I don't know, what else what other buzzword do you guys say? Cohomology, I don't even know what the fuck that is. Holograph, or infinity, you guys have no idea what that is. Physics is just kind of jerking off because nobody wants to admit they have no idea what they've done for the past 80 years. And then there's a bunch of engineering weird people telling you guys, don't stay away from the stuff that's actually real, which is so much fraud and historical nonsense it's hard to process. Any other buzzwords? What other buzzwords did I miss? Yeah, I think that's pretty much it. Metabolism, that's just some sort of processing, internalizing, calorizing mass. I don't know. I'm not going to take it on any longer than it should be. So thank you. That's what I have for today. Please pay me some money, and I will see you on the next one.